fell off.
Alright.
That's my notes.
Yeah.
Okay.
So.
It's actually terrible. Yeah. No,
It's like spicy.
you see what I mean?
It's called mango
No, it's
chili.
salty.
Oh, it's spicy. That's all the salt.
If anyone pukes in my classroom,
It's
give
not
it
me.
F.
John.
Game over.
I'm actually close.
Who thought that was a good idea?
Okay. We are spending the rest of the week on this section. If you look, the back slide has a list of book problems. Those are the homework for the section. I am not going to tell you each day, do these 5 problems or do these 4 problems. You just need to, you can start working on it. So after class today, you'll be able to start working on it. If you get something you don't know, wait. Okay, but just so there's no surprises, if you don't want to pile up homework Friday, you can start it at any point after class today.
Where was the mango?
So,
It's just
we are talking about a couple different things in this. Limits at infinity and infinite limits.
I thought you just came over and you were just taking
I was taking
my notes as my homework.
No, I was making sure I was trying to. Okay. So we know a limit is essentially telling us what does our y approach when our x gets closer to a certain number. Right? The answer to a limit is giving us a y value. The number we are approaching is our x. We have never done one of these yet, but we can. X does not have to just approach a single number. X can approach infinity. What would that mean if x were approaching infinity?
Then it would be not,
There'd be
not a
an asymptote.
function. Yeah. No, I'm sorry. I'm an asymptote, but I stopped.
Okay, if I'm asking what it approaches as x goes to infinity, I'm
Isn't it
saying
so
as
line?
x goes on. Now, it may be an asymptote, but it doesn't have to be. You know, if I think about x cubed, what is this y value approaching as x goes to infinity? Infinity.
It's just a
So we can approach infinity if we're going forever in the positive direction. We could approach negative infinity if we're going the negative direction. It's also possible for our answers to equal positive or negative infinity if our value is just getting larger and larger. So this is just a couple examples where it might approach a single number. So a horizontal asymptote would be one. Also, this is like a harmonic motion. We did a small day of that in trig, like a spring motion. You know, if you bounce a spring, it's oscillating around a center point. So that type of thing, you would have your limit as it approaches infinity is going to give us a single number. And same thing, we can go to negative infinity and get a single number. So those are cases, if you are approaching positive or negative infinity and getting an answer out, that is giving us like a horizontal asymptote. So yesterday, we had the question, I graphed a rational function, you said, how do you know where the horizontal asymptote is? And in college algebra, I just gave you these magical rules, and I said, well, if degree on top is smaller, it's always 0, and if it's same degree on top and bottom, you divide leading coefficients, and it couldn't really give you a good explanation of why, because y involves calculus, and that would have just scared you if I tried to show you the calculus reason.
No, no.
Or would have?
I would never.
Have you ever heard of
Somebody would have cried. I would have been able to fill my mug.
I'm scared.
if I tried.
I could have filled my mug.
I'm scared.
No. So it's just a limit. So we are just going to be, if I ask you to find a horizontal asymptote, we don't have to memorize rules anymore. We know it's the limit as we approach positive infinity or negative infinity.
What is arctangent?
It is possible to have multiple horizontal asymptotes. We never saw that in pre-calc because we always were graphing rational functions, like a polynomial being divided. But if you think about like your inverse trig functions, you know, tangent inverse, because tangent has 2 vertical asymptotes, when you do the inverse, it has 2 horizontal. So this is a case where it's approaching one number as you go to positive infinity and a different number as you go to negative infinity. Because that can happen, when we find our horizontal asymptotes, I'm going to tell you, you have to check both positive infinity and negative infinity. 9 times out of 10, they are going to give you the same number because we're mostly dealing with nicer functions that have a single horizontal asymptote, but we know they don't have to, so we are going to check both directions, okay? First, let's just try reading a graph and trying to identify some things. So, I'm asking for a lot of different things here. First thing, the infinite limits. That's any limit that would equal positive or negative infinity. So can you tell me anywhere where I would evaluate the limit of my function and get either positive or negative infinity?
X
Negative
approaches negative 1.
Okay, because what's happening at negative 1?
A vertical asymptote.
Yes. Didn't we see that when we were talking about discontinuities? We had infinite discontinuity there. That's also called an infinite limit. So the limit as you approach negative 1 is equal to positive infinity. My graph is going to positive infinity. Any other infinite?
Approaching 2 from the left and the right.
Okay.
So just 2.
So
No.
let's write them out separately
What would
because
be
they're
the limit
different.
at 2?
The limit as we approach 2 from the left. So if I'm coming in smaller than 2, what am I getting out?
Infinity, or negative infinity only.
And if I approach 2 from the right, if I'm coming in bigger than 2, what do we get out?
Positive.
Those are my infinite limits. An infinite limit basically means it's equal to positive or negative infinity. Limits at infinity. That's asking you to find the limit as x approaches infinity and the limit as x approaches negative infinity. As my graph goes forever in the positive direction, what number is it approaching? 4. Kind of hard to tell, I know, but so 4. As I travel forever in the negative direction, where's my graph approaching?
Wait, I'm trying to write.
Okay.
I don't understand.
As x is going to infinity, so I'm traveling along my graph and my x is getting bigger and bigger and bigger and bigger. What y are we?
Oh, what is it bottoming out at?
Mhm. All right. If you look at this graph, do we have any asymptotes?
Negative 1.
Okay, what kind of asymptotes are negative 1 and positive 2?
Vertical.
Vertical asymptotes. Asymptotes are lines, so you have to give me the equation. Vertical is x equals negative 1, x equals positive 2. So my vertical asymptotes, that's when I had infinite limits, right? My limit went to positive or negative infinity. Any other? Do we have horizontal asymptotes?
Y of 4 and Y of 2.
Y equals 4, y equals 2. So my horizontal are what my limits were equal to when my x went to positive or negative infinity. So infinite limits give me vertical asymptotes. Limits at infinity are giving me horizontal asymptotes. Any questions there? Let's see if we can figure out what this would be. The limit as x approaches infinity
Is it a chart?
of 1 over x. So we can make a chart.
1/2 x plus 0.
1 over infinity.
Perfect.
Okay, so let's think for a second. So if you made a chart, okay, let's just talk through it and then figure out what would be a good strategy moving forward. Okay, if you put in, x is getting bigger and bigger, right? So if you put in 2, you get out
1/2.
1/2, 0.5. If I put in 10, we get out
2, 5. It's 1/5. 0.2.
If you put in 10,
0.1.
Or wait, yeah,
10.
close.
if you put in 100,
It's a good
1.
Point
Oh, I
if I put in 1,000, 1 divided by 1,000.
1,000,000.
Okay, if I put in 10,000,
4 zeros.
tell me what this is approaching?
Probably
Zero. Okay, so we can make our table. We can also think about it. If I have one pizza, yeah, so that's why like we can't plug in zero, so you have a vertical asymptote at zero, and then this is giving me the horizontal. Essentially, it's my x goes to infinity. There'll be two different things. I ask you for vertical asymptote, which is like your domain. Horizontal asymptote, you have to think about. So another way to think about it is if I order one pizza, okay, and we each get a slice. We each get 1/8 of the pizza. What if I go and invite the weights class to come in? What's going to happen to the amount of pizza you get? Smaller. If I go invite Mrs. Keller's class to join us as well, it's getting smaller. So as I invite more and more and more people in, what's happening to the amount of pizza each person gets? Smaller and smaller and smaller and smaller. And it would approach zero. Because can you get a negative amount of pizza?
No.
So that's going to zero. Alright, if I was plugging in negatives, would that change anything?
It equals zero, but it comes from the other side.
Yeah. It would just be all the same numbers, but they would be negative. But aren't they still approaching zero?
Yeah. These codes for a negative amount of pizza.
Alright. So if you have a number divided by infinity, does it really matter if I have 2 pizzas or 3 pizzas or 4 pizzas? What's going to happen is I invite the whole school in here with me. It's getting smaller and smaller and smaller. So anytime we have a number divided by infinity, what's that going to turn into? Zero. It's getting smaller and smaller as we go on. Alright, so this is our next theorem, something we now know is fact. Mainly because I told you, but also because the textbook backs me up. So the limit as x approaches infinity of 1 over x to any power, it could be 1 over x squared, 1 over x cubed. If you have a power, it's just getting to zero faster. It's just going to go to zero every time. So a number over infinity is going to turn into zero. All right, so what if I gave us this one? If I just try to plug in my infinities and think about it, 3 times infinity squared minus infinity minus 2, do we really know what that's going to?
Infinity.
How do you know?
You don't.
There's a whole thing with like degrees of infinity, and we're not going that
Degrees of
in depth.
infinity?
Yes.
What?
So, we don't really know. It's probably turning into a really big number. But if you have a really big number divided by a really big number, do we know necessarily what that turns into?
A small number.
Maybe. But what if the top one's getting bigger faster than the bottom one?
Who knows?
Oh no. So that just doesn't work. So let's do an algebra trick here. What is the highest power of x we see?
2.
2.
We know that in a fraction it's legal to do the same thing on top and bottom, right?
Square root.
So I can't square root, but I can multiply by whatever I want. So what I'm going to do is take top and bottom times 1 over x squared. Because x squared is the highest power of x. Now, kind of goes against everything, because we're always trying to get fractions out of fractions, and now we're making one. But if we distribute 3x squared divided by x squared would give us 3. Minus x over x squared.
1 over x.
This is nonsense.
If you don't like that, show more work.
I just can't do fractions.
So it's 3x squared divided by x squared, x divided by x squared, 2 divided by x
Oh,
squared.
my
We're
x.
dividing every single piece.
My squared is on the x, not over the whole thing. Got it.
Right.
Now it makes sense.
1.
I
Okay.
just wrote it wrong.
So this is 3 minus 1 over x minus 2 over x squared. I can't reduce that. 5x squared divided by x squared is 5. 4x divided by x squared is 4 over x. 1 over x squared. Okay. We don't need to.
Now we have everything over infinity.
If you plug in infinities at this point, you have 3 minus 1 over infinity minus 2 over infinity squared, 5 plus 4 over infinity plus 1 over infinity squared.
3 over 5, baby.
So, because the x is squared. But it doesn't matter. If you have a number over infinity, or a number over infinity squared, what's it going to?
0.
0. So this is 3 minus 0 minus 0 over 5 plus 0 plus 0. So we get
3/5.
3/5. Remember in pre-calc I said if it's the same degree on top and bottom, you divide the leading coefficients. And so we would just look at that and say, oh, x squared over x squared, 3 divided by 5, that's my horizontal asymptote. Now we know the y. Because as we approach infinity, that's what this would turn into.
So do we need to show all the, now that we've understood why it doesn't?
You would need to show me this step and this at the bare minimum.
Okay, I can do
I
that.
can, I guess, do that.
All right. Are we okay on that one?
Kind of.
Let's
Oh,
find
no.
horizontal and vertical asymptotes of this one. I'm doing this one early on because it's one of those lovely cases where it's not necessarily the same as we approach positive and negative infinity. And I want to show you that so you know they're not always the same.
Oh, we're just
So,
finding asymptotes.
If I want vertical asymptotes, those we should be able to just pick out pretty easily. How do you find a vertical asymptote?
Whatever
The
makes the
bottom.
bottom 0.
5/3.
5/3.
But you can't just tell me 5/3. I want the equation because it's a line, so it's x equals 5/3. All right, there's my vertical. To find a horizontal, we have to do two things. We have to do the limit as x approaches positive infinity. And the limit as x approaches negative infinity. Okay, so we'll work one at a time. But I have to check both because I've told you, sometimes you could have multiple horizontal asymptotes. All right. If I just plug in infinity, I get the square root of infinity plus 1 over 3 times infinity minus 5. Does that really help me?
No.
Now I told you on the last one, we can divide by the highest power of x, right? Or we could say, let's say I want to multiply by 1 over x on top and bottom. Okay,
It would be.
Oh,
Because the x squared
Right,
is 1.
yeah.
okay,
wait.
here's why.
No,
The
it's
x squared is under a square root. What's the square root of x squared?
1.
X to the first. So if we think about this, we have to be a little bit more careful. I'm going to show a little extra work on this one than I probably will in the future, just to illustrate what's going on. Can you just drag that x under the square root? No. On the bottom, we have 3x over x minus 5x. Okay. If I need to bring this under the square root, it has to have a square root. So x would be the same thing as the square root of x to the second power. Okay, so now it's under a square root, so I can simplify this. So 2x squared over x squared, 1 over x squared. And again, I'm kind of going overboard with the amount of work, but I'm trying to make everything very clear on what I'm showing you. So on the top, 2x squared divided by x squared is 2. 1 over x squared. 3x over x is 3 minus 5 over x.
Now you can put in.
Okay, are you guys all with me to that point? So now, if we plug in our infinity, we know a number over infinity is going to go to 0. So we get the square root of 2 plus 0 over 3 minus 0, or radical 2 over 3. So my horizontal is y equals square root of 2 over 3. That one was extra ugly because of the square root. Are you guys all with me there? Did I
Yeah.
lose anyone? Okay, what step?
The second one going to the third.
So right here?
Yeah.
Okay, so we took it, everything times 1 over x. But right here, I said, I need to be able to simplify these. So I had to ask myself, x would be the same as the square root of x to what power?
Square.
So instead of an x, I changed that to a square root of x squared. They're equivalent, but I rewrote it under the square root, so then I could bring it under my radical. Other questions? Okay, but we also have to check from the negative side. Okay. Starts off the same. We know it's legal to multiply the 1 over x on top and bottom. So the limit as we approach negative infinity, square root of 2x squared plus 1 over x over 3x over x minus 5 over x. So far it's just identical, right? Here's where it's different. Before, we said that x is the same thing as the square root of x squared, right?
It's not now.
Why is it not?
Yeah, square
Negative.
root of negative.
Okay, x is a negative number, right? When you square it, it becomes positive. So my original, when it was just an x down there, I had a negative number. But once I square it and add my square root, it's now a positive number. So that means I need to throw a negative out here. Because the original problem was negative, I can't change it. The squaring inadvertently changed it to a positive, so I have to fix it by putting my negative back. Does that make sense? Okay, so now we just keep rolling like we were before. So we have a limit, we approach negative infinity of a negative. We can bring it under the radical, 2x squared over x squared, 1 over x squared. Negative 2 plus 1 over x squared over 3 minus 5 over x. Now if we plug in infinity, 2 plus 1 over infinity, 1 over infinity is 0. On the bottom I have 3 minus 5 over infinity, 5 over infinity is going to 0. We get negative radical 2 over 3. So this one has a second horizontal asymptote. Negative radical 2 over 3.
Should we say plus or minus?
Yes.
Where are you putting the zeros in? Okay.
Because I plugged in my infinity right here, and 1 over infinity will go to 0. Alright, now it's only going to happen that we get multiple horizontal asymptotes when you don't just have like a polynomial divided by a polynomial. So when we have radicals, when we have like inverse trig functions, those kinds of things, absolute values, that's when we really need to be concerned. Most of the time they are going to be identical, but I'm still asking you to verify both of them so I know that you are aware that they both exist and they have the potential to be
Will
different.
we do the grace then?
Huh?
Will we do the grace steps or whatever?
Yeah, I mean, I showed a lot here, probably more than you would have to. So at the very least, I would expect you to show me this, this, and this, and then write your horizontal.
No, I was saying like the grace, like whatever
Oh, greatest integer.
Greatest in, oh my, I thought you were saying grace.
Oh, it's like, I don't know exactly what you're asking, but greatest integer, yes. We could do them, probably won't do in here, but we certainly could. Alright. Any questions there? Right. Look at another one. Let's say I ask you to find the value of this limit. So we're just trying to get to the point where we can plug in infinity and know what it's going to equal, right? Same things that we did when we were evaluating limits before. We had to write problems so that we could plug in whatever number we were trying to approach.
Can we just evaluate the radical?
Can we though? If I put in infinity,
Well, no, like
I
can
have-
just take away the radical.
the square root of infinity squared plus 1 minus infinity.
Let's
Evaluate-
put in some imaginary
Evaluate was not the word I
numbers.
meant. I meant like because it's squared and a 1, you use an x plus amount.
It's not the whole x plus 1 squared. It's only the
I
x
would put in an
plus
x. Let's do it.
But one is already a.
If it's x squared minus 1, we could do that.
Yeah, you're trying to think like.
I just want to get
terms
rid of the radical.
Right, I know. If it were like this, then it would cancel. But here, because it's two terms, we cannot.
It's just silly.
So, maybe, I mean, it seems logical, right? Would we agree? It seems like it should be 0. Infinity squared plus 1. Seems like it'd be close to infinity minus infinity. But is there any way for us to know for certain right there? No. So think back to when we were evaluating problems. If I said, like, I want you to do the limit as x approaches 2 of 1 over the square root of x minus 2. What would you have done there, probably?
Conjugate.
Okay, we try to get rid of the square, we would multiply by it on top and bottom. If it's multiple terms, we did the conjugate. This is essentially over 1.
Oh no.
If I multiply by the conjugate, that's the square root plus x. We have to do the same thing on top and bottom. So, same strategy we've done before. All that's different is we're approaching infinity instead of a number. If I multiply the square root of x squared plus 1 times the square root of x squared plus 1, it's just x squared plus 1. Because they're conjugates, my outside and inside cancel. Minus x squared. On the bottom, 1 times this is just going to give me my square root of x plus 1 plus x. Now, it doesn't seem like we've done a lot, but we really have.
Now we can multiply by 1/2.
And actually, we don't even have to, though. So, we get to here. Right? The x squared minus x squared cancels. So the top is going to 1. Okay, the bottom, it's a little bit hard to tell. But the difference is we're adding instead of subtracting. Infinity is a big number. If you add 1 to a big number, you get a big number, right? If we square root a big number, we still have a big number. So this is a big number plus another big number. So what's the bottom? Big number. So you have 1 over infinity, which is going to 0. The reason we couldn't necessarily do that before is a big number minus a big number. We don't know which one's bigger. We don't know if it's going to go to a specific.
What happened to our 1?
But we just kind of reasoned through it because this was all adding. If you're adding together big numbers, you still get a big number at the end. Okay, so we're kind of using a combination of algebra and reasoning on this.
Inductive. Or is it deductive?
Big number plus big number is still a big number. 1 divided by a big number is always going to go to 0. All right. Let's do just a couple more for today. I'm going to skip this one. I want to go to this one.
So that's what I was pointing out.
Why would that?
I was like, question mark.
What is the limit as x approaches negative
Wait.
infinity of e to the x? Okay, I'm just asking you to evaluate this limit. Can we figure it out?
Probably. Is it 1?
It's a natural law.
Okay.
Yeah.
So if you plugged in infinity, you have e to the negative infinity, right? What does a negative exponent do?
1 over
Oh.
a.
Alright. If you take a negative exponent, rules of algebra just moves it to the bottom of the fraction. Okay? E is a number. You take a number to a really big power, what are you going to get out?
Really big number.
Really big power.
So 1 over infinity is going to go to 0.
Bro.
Of course.
So I
Why-
can just make things infinity just because I'm just gonna guess that.
Well, we know e is a positive number. If you take a positive number to a power, and if that power keeps growing, think about exponential functions. They keep growing and growing.
Can you explain why 1 over infinity is equals 0 again?
Okay, I have one pizza,
Oh, so it's that one.
and I'm inviting more and more people into
Okay.
the
So I have
bus.
1 pizza.
Yeah.
Okay,
So
sorry.
I have a
Pizza.
It's a test. I'm gonna be like, I have one pizza.
It's just
A
the way.
pizza.
How do we know he's possible?
It is kind of like pi. It has a set value. It's a 2.78.
Yeah. It's
I
exponential,
just like
right?
Andrew
It's
is like,
exponential.
yeah, can you? I have a pizza, okay?
Really? Yes, pizza.
End of story. I have a pizza. That's all we need to say.
Please. On the ACT,
I'm
they're
so
gonna-
On Monday, when that guy's in here, I'm just gonna be like, so we have a pizza. And you guys are gonna be like,
Oh.
yes, oh, makes perfect sense.
Please, anytime we ask any question, you need to be like,
So,
all right, so
yeah.
I got this pizza.
Even if it doesn't apply.
Imagine, yeah. Even imagine I had this pizza.
It's undefined. What is that?
Okay. Let's take, I would like to get through
From the left.
1 or 2 more. If I am approaching 0 from the left,
Okay, so those are negative numbers. Plus 0.
Wait.
should be the next
And example 7.
Oh, my thing's.
Oh. Okay.
Dang.
Possible.
We are really using our deductive reasoning here. So if I were to plug this in, this is e to the, can you do 1 divided by 0?
No.
Okay, but we can think about this.
Okay.
First of all, it's 1 divided by a negative number because I'm approaching 0 from the left, right?
Sure.
So if you have a positive divided by a negative, you're going to get a
Negative.
negative. Okay, I'm approaching 0, so I'm getting closer to 0. So think about, if I did 1 divided by 0.1, what does that give me?
Oh,
A big
really,
number.
a really big number.
1 divided by 0.1 is 10. 1 divided by 0.01 is
100.
100. 1 divided by 0.001
It's
is
1,000.
1,000.
My pizza's getting bigger.
This is approaching negative infinity. The negative because I'm getting closer to 0 from the left. But, okay, think of it another way.
What?
I'm approaching 0. I have my 1 pizza. We have the whole school in here. I start kicking kids out. What's happening to the amount of pizza you're
Getting
getting?
more.
You're getting more and
It's
more and more.
spawning back
It's
in.
rising.
How am I get that pizza? Wait a minute.
Okay, think about it. I have a pizza. Just,
What?
I started on
Okay.
pizza now.
yeah, I don't even know
Okay.
how to get out that pizza.
So, let's just talk about
Is it cheese, pepperoni?
if I am approaching 0 from the left. They're smaller than 0. So if I take 1 divided by negative 0.1, we get negative 10. 1 divided by negative 0.1, 0.01, is negative 100. 1 divided by negative 0.001.
So it just keeps getting bigger negatively.
The pizza
Yeah.
was so
So
funny.
it's going to negative infinity.
Pizza was so funny. I started having an
I
asthma
want to
attack.
have a pizza.
So, but we know, what does e to the negative infinity go to?
0.
Yeah, because that's
It does?
1 over e to the infinity.
Oh,
And 1 over infinity.
bro.
So really, we still have no pizza.
Who
Well,
let these freaking people
I really
come up
want-
with calculus?
Because we're used to so concrete, and now we're trying to like.
So like.
See
is
beyond.
there-
I
is there
see.
going to be an
We're gaslighting
instance, which
ourselves.
I probably shouldn't even ask.
So I
what's
have a-
going to happen where this is not
No, you
going to
don't.
be running zero.
Yes.
If I had
Perfect.
more people-
Oh yes, next
That's
question.
what our
Question.
last problem of the day.
Ooh,
Sign.
when we
Yeah,
got this,
sign.
let's think about it, right?
Okay. What does sine do?
Wiggle
Okay,
wobble.
bounces back and forth between -1 and 1. As I go to infinity, does it ever quit bouncing between -1 and 1?
No.
So does it ever approach any single number as I'm going on forever and ever and ever?
No.
No. So what would my limit be?
Does not exist.
Oh my